Hi everyone, welcome to today's class. I want us to look at physics practical or alternative to physics practical, and what I want us to look at is the verification of Archimedes principle. Of course, most times the same thing can be related to heat energy, but this one now we're not going to heat anything. Just like this, remember this is alternative to practical. It is not performed in the laboratory, so it is performed elsewhere. And then we are demanded to make a certain do certain measurements here and make deduction. Now from here, if you look at this, we have this is a beaker where a certain containing water anyway. Now we have a rigid support. This rigid support from there will have mass completely immersed, and then this is our meter rule, which is the scale. And of course, the moment we immerse it, the level of water column rises. So this is what you want us to do now. Join me, let us do the thing. And at the end of the day, we have one of our scales here. This is the scale is measured, of course, the weighing balance measured in grams, the length here. So join me, let us do these calculate these deductions and make measurements, and then come out with our result. Okay guys, this is number one, and this number one question says you have the diagram here where we have the rigid support, and after the rigid support we have this is a meter rule to measure the height of water column. Now this is the D there. Okay, now let's go. The question says we'll take the instruction first. The instruction says the internal diameter D of an empty beaker is measured. Water is then poured into the beaker until it's about 2/3 full. The depth D0 of the water in the beaker is measured using a graduated scale fixed to the beaker. A body of mass M, which is this, supported on the free end of a piece of thread fixed to the bus of rotor stand, is measured completely, is immersed completely in water as shown in the diagram above. The new depth di of the water in the beaker is measured and recorded. The procedure is repeated with 4 different masses. Figure F1A, F1B, F1C on page 3 show the masses masses MI, the diameter of the beaker, and the depth DI of water in the beaker respectively. Now, having read that, let us look at those images. Now, this is we have a figure 1. This is a figure 1. We have 1A here. We have 1B here. Now the figure 1A shows the masses, and of course you can have here M1 here, M2 here, M1, M2, M3. We have here as our M4 and here as our M5. Of course it is measured in grams, so we take note of that. Now we're going to move to figure 1B. Figure 1B shows the diameter of this beaker, so we are going to measure it, while figure 1C shows the depth or height of water column or depth of that beaker. Now take a careful look at this. We have from here, we have this is 1C. This rule, if you look at this here, is 0 cm. At a point, it was cut, and then we have from here, we have 2.8 D1, D0, D1, D2, D3, D4, up to D5. Now, the implication of this means that, yes, you cannot start, even though 0 is written here, you cannot start from 0. Instead, the thing was breached at a point. It was breached. So everything you do when I start from 2.8, so it means that from 2.8 downwards, not captured. So if you measure, whatever you measure from here, you add these 2.8 to that value to give you the exact value. Okay, now let us go back to our question. Now, having read this, we have read up to here. Now, question 1 says, measure and record the masses Mi and the corresponding depths of that beaker, Di, where I is an integer from 1 to 5 respectively. In each case, evaluate Di minus D naught. Also, measure and record the capital G. And of course, there are just 3 items here. We have the masses, those masses there. We have the depth of the beaker, and we have the diameter of the beaker, capital G. At the end of the day, they say, tabulate your readings, plot a graph of Mi on the vertical axis against D minus D naught. That means in this case now they have given us what I stand for. So we are going to plot a graph of mass against D minus D naught on this one on the vertical axis, while D minus D naught on the horizontal axis. Determine the slope S of the graph. Evaluate K is equal to 4S all over pi D squared, where pi is 22 over 7. It said, state 2 precautions you would take if you were performing this experiment in the laboratory. Now we move into action. We now go back. So everything will now border on figure 1A, figure 1B, and figure 1C on that page 3. So we are going to measure M, measure D, capital D, which is the diameter, and then measure the Di and that of D naught. So now the first thing we do is we'll take a look at that again, and then let me wait a little bit so that you can see it. Okay, we have here as our M1. Here is our M1. If we read this, from 0 to here is 100, 200. Now, if you count the number of graduations here, let's count it together. Of course, we're not going to count the first one. This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 calibrations. So it means, and of course, here is the fifth one. If from 0 to 100, from 0 to here is 100, and there are 10 calibrations, that means we have as our M1 will be what? 50. M2, which is at 100. Be careful. So this is 100. If you look at this one, it's in between, which is 150. Look at your M4. M4 is 200, while M4 is 250. So we make our table of value. So our table of value will now look like this. So this is our table of value. Having drafted our table of value, all we need to do is to fill it up. The first thing you do is, with the values given to you, draw your table of values. So those tables to make work easier for you, so that you don't forget any material or any item. So now these are the items given to us: the mass in grams. This is D, which is the diameter of the beaker, and of course it's just a single value. You may decide to write it on top here, on top of your table, or create a column for it and then draw the values down. Now we have D naught. Of course, D naught also is just a value. You may decide to write it on top of your table or create a column for it. Now we have before this we have D. We'll draw column for D and then column for D minus D naught. So let us move. The first thing now is to get our masses. Now our masses, from what we have here, we fill it up. So this one is 50, 100, 150, 200, 250. We'll write it. We have 50, and of course you don't write just 50, 50.00, 100.00, 150.00, 200.00, and then 250.00. Now, having the next one now is to measure the diameter. The diameter is just a single value. Now, this is our diameter. Now, this diameter we measure. Place your ruler very well. If you place your ruler, if you look at it, this is what we have. And then it will now give us, make sure the 0 column is coinciding with this. And then make sure you avoid 0 error. Now, if you read from here, and of course, this will give us 6 here. This is 6.5. 6.6. It's not up to 6.7. This mark here is in between 0.6 and 0.7. So we make it half to now give us that D is 6.65. Since it's just a single value, it's either you write it on top or you create. If you create a column for it, you drag it down. You fill it. 6.65, 6.65. Okay, I won't fill that one. Next one is our D naught. We'll get our D naught. For us to get our D naught, remember, no scale whatsoever was given here. Since no scale is given, we read directly. Now, if we are measuring, we'll now have, of course, permit me to measure like this. Now, remember, we said we're not going to measure from here. We rather measure from this. So, make sure it's coinciding. Now, from here to here, this is 1. This is 1, 2, 3, 4. So, as the case, this is a 1.0. Now, 1.0, you add these two. You add these 2.8 to 8, and it will give us 1.0 plus 2.8 will give us D alone is a 1.0 plus 2.8 will give us 3.80. Since it's just a single value, you fill this, you fill it up. 3.80, 3.80. You fill it. Now, the next thing now is to, before this, let us get our G. Now, we go back. Remember, this is our D1, D2, D3, D4, D5. Started from here. So, we measure from here up to here. Now, if we measure it, we are going to get, if we measure from here to here, well, this is a 2. D1 is 2. So this 2 added to the from here to here is 2. Add this 2.2 here. Add it to give us a 4.8. So we have it here, 4.80. Now we still measure this one. The next one, if you measure it, is this is D2. D2 is 3. This one is from here to here is 4. Right to here is 5. From here to here is 6. In order not to waste our time, we still do. Okay, let's finish up the second one. The second one is 5.8. Now we put it down, 5.80. The next one is 6. Is, of course, this is here. D3 is 6. From here, from down to that place, will give us a 6.80. So 6.80. Now the next one is, if you look at it, still here, 7.80. So we have 7.80. The other one is 8.80. So if you need this material, please chat me up and I will send these materials to you. I will scan it and send to you. You take your measurement as well. Now, having gotten this, the next thing we are going to do is to fill up this column. Remember, D minus D now. This is D. And D is 4.8. 4.8 minus 3.8 will give us 1.00. Now, the next one is 5.80 minus 3.80 will give us a 2.00. This one minus this will give us a 3.00. This and this 4.00. This and this 5.00. Now, having filled our table of value, the next thing now is to plot this graph. Now we'll go ahead to plot. Remember, the instruction for plotting says, we'll take it. They said plot a graph of MI on the vertical axis against a D minus D naught on the horizontal axis. So we draw our axis. Now for the graphing, now I have ruled vertical and the horizontal lines. So we have this is where the line ends. Remember, here we are plotting a graph of M. So for benefit of doubt, let me show us again. So say plot a graph of M on the vertical, D minus D naught on the horizontal. So here we label. This is we label here as our M and the other side as our. So we have M in grams. Now on this side we have here to be D minus D naught. Always remember to put the SI unit, centimeter. The SI unit is there as cm. Now the next thing, because I want to start from the origin, always remember to put here 0, 0 here. This has 1 mark. Now do not disregard this instruction that said M here and D minus D naught here. Now the next thing now is to calibrate label our axis. Now here we have, if we use 10, 20, 30, 40, we cannot be able to get the maximum. So if you check here the screen there, we discover that the highest value on the M axis is 250, while that the least is 50. Now for D column, we have that the highest is 8.8, while the least is 4.8. Now we have here, we can decide to write 50, 100, 150, 200, 250 at least. The highest value is up to half of this. Remember, they cannot give you the whole of this. So if you check the graph given to you, you now know what to do. But please ensure you don't space your work out too much. So we have here as 50, we have here as 100, 150, we have here as 200, 250, 300, 350, and 400. Now make sure you label this other side too. Remember, you can have here to be 1. I can have here to be 1. I have here to be 2, 3, 4, 5, 6, 7, 8, as the case may be. Now we have next thing now is to start plotting. Remember, the highest value for D minus D naught is 5.0. So we plot the first one. The first one, we are plotting a graph of 1 against 50. So this is 50 here. This is 1. Remember to use a sharp pointed pencil. We have here, we plot somewhere here. Now the next one is to plot a graph of 100 against 2. Now this is the 2.0 here, and we have 100 here. Now we plot. Remember, even though this line is faint, but it's somewhere here. 1, 2, 3, 4, 5. That is what we have. This is the 5th line. So we are going to plot here. So this is we are plotting here against 2. Now the next one is we plot a graph of 150 against 3. 150 against 3. So this is 150 here. Now we'll trace it down. It will give us 3. So if we trace it down, we plot somewhere here. Please don't mind this one. Now the next one is to plot a graph of 200 against 4. So here is 200. If we trace it, we have 4. This here is the meeting point. We plot somewhere here. Now the next one is a graph of 250 against 5. Now this is the meeting point of 250 and 5. Now we plot somewhere here. Now if you look at this graph now, this is a very straight line graph from the origin. So we put our line of best fit, and remember the rule, everything must not enter the line at the same time. So we have this automatically from the origin. We'll now plot here. This is our line of best fit. This is a straight line graph. Now the next thing we'll do is to draw our triangle. Remember, we must draw a right angle triangle, a bigger one for that matter. So we can start from here. We can start from here and then bring it up to this point. Make sure it's straight. And then we can now pick from here. We can pick from here and then bring it up to here. So now if we so desire, though it's not compulsory, we can make a mark here from here up to here. We can make a mark here and put arrow here. Remember, it's not compulsory, and write delta, whatever you have on your vertical axis, which is m. So we can have here as a change in m. Now we can still do the same here if we so desire, though not compulsory. If we so desire, we can do this here and then put arrow here, and write delta d minus d naught. Remember, it's not compulsory. Now we can now check what we are doing and then read our slope. Remember, you don't write on the graph. The highest you can write just these two. For your slope, I can use I can write here for the slope. Let me read. So once I read, I can write here. Now remember that the highest column, this is 250 somewhere. If you read this thing up to, it is 250. So we now have that our slope is equal to change in m all over change in g minus d naught, which will give us the highest value here is 250. We put 250 minus, now the least value here is 50. We put it down, 50 all over. Now what you have here, this is 5 minus 1. So we have 5 minus 1, which will give us, should now give us 50 minus 50 will give us 200 all over this minus, which will give us 4. Now 200 over 4 will give us 50. 200 over 4 by a calculator will give us 50. Remember, this one is in grams, this one is in cm, so it will now give us gram per cm as our SI unit. So this is our SI unit for the slope. Now, the second question says, the next question says, after plotting the graph of this against this, determine the slope. We have done that. Now, evaluate k is equal to 4s all over d squared. K is equal to 4s all over pi d squared. All over pi d squared, which will now give us 4 times slope. Slope is 200. Slope is 50 all over pi. Pi is 22 over 7, which is 3.142 times d squared. D is our diameter. Our diameter is 6.65. So we'll check. Remember, it's in cm. So we have a 6.65 all squared. Now it will give us that 4 times 50 will give us 200 all over 3.142 times the 6.65 squared will give us 44.22. Now it will give us 200 over 44.22 times 3.142. It will give us 138.94, which will give us 200 all over 138.94 will give us 1.44. Remember that the SI unit, this one, the S is S here is grams. S is gram per cm all over. This one doesn't have SI unit. This one is a cm squared because of the square here, cm squared. So if you send it up, you now have g c m raised to the power minus 1 cm raised to the power minus 2. So if you bring them together, you will now have g cm raised to the power minus 3. So this is our SI unit. Therefore, we now have that k is equal to 1.44 gram per cm cubed. Okay, so this is a answer to that question. Now the next question is state 2 precautions taken to ensure accurate. State 2 precautions you would take if you were performing this experiment in the laboratory. And of course, one of the precautions we would take is remember, there is a measurement here. There's a measuring instrument here. So one of the precautions to take is I ensure there is 0 error when taking my readings. I noted and corrected 0 error of this meter rule. That is one of the precautions you take. I noted and corrected 0 error of your meter rule. Second one, I avoided error due to parallax while taking my reading. So if you are taking your readings, you take it straight. So you don't take it at an angle. So you said, I avoided error due to parallax while taking my readings from the meter rules